Let's discuss the educational code forces round 152 problem C. This was really a very nice problem. Okay, binary string copying. So you have been given a string S. So you have been given a string S consisting of n characters 0 and or 1. Okay, and what you have been told you is that you have to make m copies of this S string S. Okay, and you have to perform some corresponding operation on the each of the copies. Let's suppose the ith copy is named as string ti, then you have to perform exactly one operation on each of the copies, and the operation is like that you have to sort its substring between l comma r. Okay, so the substring from the lith character to the rith character, both endpoints inclusive. Note that each operation affects only one copy. Means if you perform operation only one copy of the string, then it will not affect any, it is not going to affect any other copy. Okay, and each copy is affected by only one operation. So your task is to calculate the number of different strings among t1 t2. Basically t1 t2 tm are the m copies we have obtained of the string s. Okay, so we have to determine, after performing the operation, corresponding operation on the corresponding copies of the string s, what with the number of different string we would get. Okay, so let's discuss the input pattern. First of all, you would be given the number of the test cases t, and then two integer n comma m, and the length of the string s, and the number of copies we have to make. M is the number of copies we have to make. The second line contains n characters 0 and 1. Basically we would be given a string s, and uh, then m lines follows, and in the ith line, m lines are what that we have what the range in which we have to sort the substring in the ith copy. Okay, so basically if I say that it is 1 comma 2, so in the first copy I would have to sort this substring between 1 comma 2. So that's how we have to perform the operation. Let's discuss the example first. Okay, so this is the example, first example. Now I have to sort this for the first copy 1 comma 2. Okay, so you can see here the underlying part is 1 comma 2. So if you sort then this the string will become, the copy would become like this. Okay, 0 1 1 0 1 1 0 0. Okay, similarly for 1 comma 2, for the second copy it would become like this, and for the third copy the string would become like this, the copy would become like this, the fourth copy, and this fifth copy. Then you can see that the number of unique strings we can get here is that these two strings are same. Similarly these two strings are same, and this one string is same. So I can say that I can get only three distinct strings. Okay, after performing the corresponding operation on the corresponding copies. So here you can see the answer is 3. Okay, so before going to the solution part, one thing you should notice here, that suppose I have given you a string 0 0 1 0 1 0 1 1 1. Then how can you say that this string is unsorted? Because the 0 and 1s are not in its correct position, and which 0 and which 1s are not in its correct position. I can say that the string between the substring, this substring is not in its correct position. How I am able to do how am I am able to say this? Because if it is one, it was in its correct position, then it would have been something like this. Okay, so one thing you should notice, even in the sorted part, what I can say, the last position of occurrence of 0 is before the first occurrence of is the position of first occurrence of 1. If any string, this condition holds this condition holds that the last position of 0, last 0 is less than, position of last 0 is less than position of first one, then I will be able to say that this string is sorted. Okay, so that's a basic observation behind this problem. Okay, so I can say that all the if I am performing the, and one thing also, if I am performing between L comma R, then the rest of the string would remain the same as the previous string S. That's quite obvious. If I am performing the operation between 1 comma 2, then obviously the whole string except this range would remain the same. Only that part would differ. Okay, suppose this is the range L comma R, and I determine L1 comma R1, a substring in this string, which is the basically this unsorted part, and how I can determine this? By using this condition. If it doesn't hold, then obviously that part is unsorted. uh, let's move on to the previous example. If string was like this, so I can say that this is sorted, this is sorted, but this is unsorted part. So how I am able to say this, that I will first determine the first occurrence of one. First occurrence of one is this, which is at index 2, if I follow the zero based indexing. Okay, and the last occurrence of one, and the last occurrence of zero, which is 2, 5. It is 5. You can see this condition is violating in this range. Obviously, if I consider that this was also a substring L comma R, then this was L1 comma R1, means this was the part in the substring which was unsorted, due to which this was unsorted. And now if I am performing the operation on L comma R according to the given operation, then this would become sorted and the whole substring would become sorted. So I can say that this string, suppose this was the initial string, and after sorting it would become like this: 1 1 1 1 1. So I can say that the this string, the new string I have got, differs because of only this range, L1 comma R1, because of only this range L1 comma R1. So that's the main observation, that's the main intuition behind this problem. I have to just, the thing which matters to me is only the unsorted part in every given range. And if I, because I can say that the each copies of the string would differ only because of the range which was unsorted in that part. And if that part is unique, then that makes this string unique. Okay, so I can say that I will just push this L1 comma R1 for each of the corresponding L comma R given. Okay, I will find L1 comma R1 means the unsorted part in that substring, means the range I will push in a data structure, and which data structure, which determines the distinctness, which determine, and that is obviously set data structure. So I will just determine this L1 comma R1, which is the unsorted part in this the substring L comma R. Basically I am talking about this is L comma R given, and I have to find L1 comma R1, which is the unsorted part in this substring, and I will just push this L1 comma R1 in my set data structure. And finally whatever I will just whatever will be the final element in the set, that would be the my unique answer, that will determine the unique string I can make after performing the corresponding operation on the given string, or the copies of the given string. I hope I have explained enough. So what would I have to do just to find, for finding L1 comma R1, to just to find the first occurrence of 1 and the last occurrence of 0. And if it is holding that last 0 is less than first one, then obviously the string is already sorted. then that copy is already sorted, so I the operation won't make any changes to the string. So obviously I can say that in that case the string would revert back to the same string, the string s only. Just in case, you can consider these two example, that this part was already sorted. 2 to 4 was already sorted in string s also. So that's why this string become the s itself. And also 5 comma 5, does it make sense to just sort one, just single element, just single character? So that's also doesn't make sense. So it will just revert back to the string as itself. Okay, so that's what I am talking about. So let's move on to the solution part. I hope it has become clear now. I will first of all take the input. I have already taken the test cases here, n comma n. Now I will take the test cases. Now while t minus minus, c input n comma m, then I will take this input string s, and I will also require a prefix array. Although that's depend on the implementation, I am why I am using the prefix array, I will just explain it later. Okay, so the prefix of I store what? The number of ones. It will store, prefix of I will store the number of ones I have encountered till index I. Okay, so I can say prefix of 0 equals to s of 0 equals to 1. If the first index is 1, so obviously the our first entry in the prefix array will be 1. So now for int I is equals to 1 to less than n I plus plus, I can say what? Prefix of I is equals to prefix of I minus 1 plus s of I equals to 1. Now int l comma r, I will take l comma r, which is the range in which I will take the range, while while n m minus minus, because basically we have to perform m copies. Okay, I will take for each copies, I will take the range, and since I am following zero based indexing, I will just make it as according to that only. Suppose if l is equal, first would I, what would I have found? That's why I have declared prefix array. I will say why. Suppose if 1 is number of 1, count 1, I can say count 1 would be what? Prefix of r, and if l is greater than 0, I can say count 1 minus equals to prefix of l minus 1. You should know that the prefix array, since the prefix of I store the number of ones I have encountered till index I. So what does this indicate? Prefix of r, the number of ones till index r, number of ones index till index r, and if I want between the l comma r, so suppose this is l minus 1 index, then it is l, and then it is r. So what I can say, I am just want to obtain the number of ones between l comma r. So I would have to obviously, suppose this was the starting index, 0, and I want the number of ones between l comma r. So obviously what I can do is that I will first obtain 0 from number of ones from 0 to r, and I will have to just subtract 0 to l minus 1. That's what I am doing. So okay, and before also I would require one thing also, before vector of int 1 comma 0, 1 comma 0, which will store the indices where the 1 and 0 are present. For int I is equals to 0, I less than n, I plus plus, if s of I equals to 1, then I would just store it in the 1 vector. I have defined the pb as a macro for the pushback. Okay, else I would push back in the 0 vector, pushback I. Okay, now what I can say here is that If L is equals to R means it doesn't make sense to, let's declare a set. Again I am defining a macro for the pair int comma int. You can see here pair int comma int as pi. Okay, pi st. I am naming the set as st. Okay, now if L is equals to R, then obviously it doesn't make sense to just sort one character as it would already be in sorted order. So the in that case I have already discussed the string would be the same as the string s. Okay, if this is so, or count 1 is equals to r minus l plus 1. What does this r minus l plus 1 indicates? The length of the substring I am considering. Okay, if what does this condition indicating? If count 1 is equals to r minus l plus 1 means all the characters between L to R is 1. So in that case the string is sorted, no, between range L to R. So in that case also the string would reverse to the same string. If count 1 equals to 0 means all the strings are 0 in that range. So in that case also the substring is sorted. So in all these cases I can say that there doesn't exist any unsorted parts. So I can just push back such as integers which is not possible. It again depend on your implementation. I am just pushing -1 comma -1. Okay, and I will just continue. If it is not so, then first I will have to obtain the position of the first one and the position of the last zero, occurrence of last zero. Okay, in this range, in which range it is L comma R. And why I have done this checker, count 1 is equals to 0 or count equals to R minus L plus 1, just to make sure that in this range means between L to R there do exist at least one and at least one zero. Okay, because if it was not so, then obviously I would have encountered this condition. Okay, so in first one, index of first one, how can I found that? By using the lower bound function of on 1, array 1, and I will have to what would be the index? I just want the index of 1 which is, suppose this was L and this was R. Okay, so I want the position of 1 somewhere between L to R. That's why I am passing lower bound as, okay, -1 dot begin. What this all is, you can see here, it is a macro x dot begin. Basically it is 1 dot begin comma 1 dot end. Okay, now if f of 0 uh, L0, that is last 0. L0 means the last position of the occurrence of 0. How can I found this? If I just found a position of 0 which is after R, suppose it is index I, it is index I, suppose it is index I, then what would be it? The position which is position of 0 between L to R, obviously it would be I minus 1. Means in the array L0, in the array L0, whatever, basically L0 store the indices. I am talking about this I corresponding to the 0 array. If I minus 1 I consider, then it would be in the array itself. Okay, so upper bound on 0, I would just pass R minus 0 dot begin. Okay, since I am sure that exact at least 1 0 and 1 ones occur, so I can say that position of 1 is equals to position of f1. You should try to understand this why I have written so, because one was the array vector, I can say, which was storing the indices, and this if f of 1 was according to this vector, but I want according to the given array, given string s, means the position. That's why I am the position according to the string s would be stored in the 1, and at this index f of 1 I want this value. That was I was trying to explain. L0 minus minus. Why I have done minus minus I have already explained, because if it is greater than r, then obviously if I just go one position back, then it would be between L comma R. So L0 I can say is equals to 0 of 0 of L0. Now if L0 if L0 means the position of the occurrence of the last 0 is less than position of the occurrence of, suppose if it is greater than uh, first occurrence of 1, then obviously this part is unsorted. This part is unsorted. So in that case I will have to just push it into the st.insert this range itself. Because of this part only, this string is differing from the other strings. I can say f1 comma l0. Else if it is not so, then this indicate that that part is already sorted, so obviously it will be the same condition as this. So in that case also I will just insert -1 comma -1. You can insert anything. So after coming out of this, I would have just print st.size. Let's see whether it is running fine or not. You can see here that it has been passed. So yeah, that's all about the solution. Thank you.